Okay, so this video we're looking at the practice problems for working with sequences and series without a calculator. All right, so if we want to write the first four terms of the sequence, remember if you are not told, start with n equals 1, and remember for a sequence you're going to use commas. So if I consider n equals 1 for this first situation, I know that 3 times 1 plus 1 is going to be equal to 4, so my first term is 4. Then what's happening? My next term would be 3 times 2 plus 1, and that would be 7. And so my next term is 7, and I can see that I am adding 3 each time, and I want the first four terms, so there are the first four terms of the sequence. Once again, remember to use commas. If I have for part B, negative 2 to the n, right? So remember, if we're not told, start with n equals 1. So I have, right, negative 2 to the first power, which is negative 2. Then negative 2 to the second power, which is going to be equal to 4. Right? Then I have negative 2 to the third power, which will be negative 8. So my first term is negative 2, then 4, then negative 8. And realize that each time I'm multiplying by negative 2, so my fourth term would be 16. This is what we call an alternating sequence because I alternate between positive and negative terms. All right, for C, I have 2 minus 1 over 3 to the k. All right, so once again, I'll start with my counter at 1. So I have 2 minus 1/3, then I'll have 2 minus 1/9, then I'll have 2 minus 1/27. Right, and I just need to separate my terms with commas. So I want to be careful about this. And I don't need to simplify the work if I don't have a calculator, but I certainly could. So one way to express the answer would be to say 2 minus 1/3, comma, 2 minus 1/9, comma, 2 minus 1/27, comma. Right, and what would be my last term? My last term would be 2 minus 1 over 81. Right? So certainly I could list my four terms like that, but if I prefer to write my mixed number in proper fraction, I could say, well, 2 is really just 6 over 3, so that's going to be 5 over 3. 2 is really just 18 over 9, so that'll be 17 over 9. Right, 2 is just 54 over 27, so that would be 53 over 27. Right, 81 times 2 is 162. Right, so minus 1 would be 161 over 81. So either of those, right, either of those is okay. You don't have to simplify your work unless you're explicitly told to do so when working with sequences in series. All right, if I look to my next one, once again, remember that your counter is going to start at 1. And so I have my first term as negative 2 over 1. My second term as negative 2 over 4 because it's 2 squared. Then negative 2 over 9. Then I have negative 2 over 16. Once again, I would recommend not simplifying those terms. As I continue, the next part says find the indicated term of the sequence, where in this case u sub n is given by my particular values. So I want my 25th term. So that means, and really this should say u sub 25, that means that u sub 25 is going to be negative 1 to the 25th, right, times 3 times 25 minus 2. Okay. Well, negative 1 to the 25th, that's an odd number, so I'm going to have negative 1. 3 times 25 is 75, minus 2 is 73, so my 25th term is going to be negative 73. Okay. If I look to this next piece, wow, I have a lot of things messed up on this one. My apologies. My counter seems to be K, so I should have a K. And I'm saying my W sub 11, so I should have W sub 11. but I want to figure out, well, what is the 11th term? Well, W sub 11 is going to be 4 times 11 all over 2 times 11 squared minus 3, right? And once again, you don't have to simplify necessarily, but you can if you want. This would be a numerator of 44, a denominator of 2 times 121 minus 3. 2 times 121, that's going to be 242, minus 3, that's going to be 239. So I would have 44 all over 239. All right. Then if I continue, write an expression for the nth term of the sequence. Well, I want to see if I can find my pattern. And in this case, it looks like I am adding 1 each time. So I could say that u sub n is going to be equal to n minus 5. And that would be my term. Why? Because each time I'm adding 1, all right, so I'm going to have 1 minus 5, then 2 minus 5, then 3 minus 5, then 4 minus 5, and that gets to my terms. If I look here to this next one to try and see if I can find my pattern, it looks to be that I'm subtracting 3 each time, so I have a common difference of 3. And so u sub n would be equal to negative 3n. And then I've got to figure out, well, how much would I add or subtract if I'm going to start at n equals 1? And I would say plus 84. Because if n is equal to 1, I'm going to have negative 3 plus 84, which is going to be 81. Then I would have negative 3 times 2, which is negative 6 plus 84, which would be 78. So there is my nth term. All right, if I look to my next piece, we get this hint that 1 is equivalent to 2 over 2. So I'm going to rewrite this as 2 over 2, 3 over 4, 4 over 8, 5 over 16. And so we can see our pattern here. It looks to be that the numerator is increasing by 1 each time, while the denominator is a power of 2. So I might say it's going to be n plus 1 for the numerator and 2 to the nth power for the denominator. And so there I have my nth term. All right. So here we're trying to see our pattern, and we're like, hey, what's the pattern in the denominator? Well, in the denominator, it seems to be that I'm adding 3, then I'm adding 5, then I'm adding 7. So my denominator goes 2, 5, 10, 17, which means that my differences are 3, 5, 7. So that means that because the second difference is the same, I'm going to be based on n squared. And if I think about n squared, this seems to be the denominator is going to be n squared plus 1. So I'm going to have u sub n is going to be 1 over n squared plus 1. And for working with these without a calculator, we're trying to find the patterns. And in finding the patterns, we want to be able to demonstrate our understanding. In the next video, we'll talk about how to do this work with a calculator. Thank you for your time.